it is more easy to observe data without affecting the performance of their applications because they don't need to instrument their code. They don't need to redeploy their application again and again. So eBPF makes the whole process easier and faster in terms of the application performance.
This is DevOps Paradox, episode number 222, Finding Performance Bottlenecks with Ddosify. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick.
Recently we had Liz Rice on, and she's let's call her the queen of the eBPF.
Something like that.
And she went into the depths and the gory details of eBPF. But today we have some friends on from Ddosify. We have Kursat and Fatih. How are you guys doing?
Yeah, we are good, thank you.
I brought up eBPF because currently, of course, Ddosify is a company. We'll give them time at the end to go deep into that. But one of the things that they're working on right now is bringing eBPF into their product. Either of you can answer this question, but what has that process been as a developer to actually bring eBPF into something that has existed for a while?
In the current products, a lot of people using OpenTelemetry to collect the logs, traces, and metrics and send the data to the backends. But this requires code changes in their products. What we are trying to do is writing an eBPF agent and deploying the agent into their Kubernetes nodes, and we can collect the traces, metrics, and logs with the agent without requiring a sidecar or any other changes. We can easily observe the customer's data.
What's the difference between writing let's say a normal code, however you were writing it before, and eBPF? At least I know that quite a few projects have real difficulty transitioning their existing code base into eBPF because it's quite different. I guess in your case, the problem is not necessarily transitioning because you might not have had the agent before, but how does it look like? What's the difference between normal and eBPF?
The customers need to write the code, and since we are a no-code company, we do not want our customers to write code.
I meant more like for you. How does it differ now that you're writing eBPF code yourself? Before, Ddosify didn't have any of that, right?
We are focusing on the load testing side in the first times of the company. Then we observed that our customers need observation about their CPU usage, memory usage, and other things. So we saw that eBPF is a trending technology and we want a part of it.
So as what Fatih said, we just focused on the load testing side at first, but after a series of user interviews, we realized that the biggest problem is finding the performance bottlenecks on their system. So the customers have pain points on both load testing tools, on both APM tools. On the APM side, they have to instrument their code, and this instrumentation makes their codes longer, and they have to deploy the new changes along with the new observability requirements. That's why we started to focus on the eBPF side, because it is more easy to observe data without affecting the performance of their applications, because they don't need to instrument their code. They don't need to redeploy their application again and again. So eBPF makes the whole process easier and faster in terms of the application performance. So we are penetrating the observability side as a company, and we decided that the eBPF will be the great solution to change how the observability works on the companies.
So you saw when working with your clients that their performance testing was Was it just too much of a pain for them to do, or was it something else?
Actually, let's take a look at the bigger picture. So at the end of the day, they want to find the performance issues on their architecture, on their system. So sending a traffic with the help of the load testing tools is the first step of this. They have some pain points in there because creating a user scenarios, sending a massive high load to their system is a pain point. They have to build their load testing infrastructure, or they have to use some commercial tools. But another stage is finding the bottlenecks. To find the bottlenecks, they have to collect metrics, collect data, and create dashboard on their APM tools, and correlate the collected metrics with the sent requests to find the bottlenecks. So there are pain points in both of these stages. On the observed side, actually we solved the load testing side because with the help of Ddosify, it is very easy to create massive loads with no-code UI and from all around the world. On the observed side, their pain points is they have to instrument their code every time they want to collect new metrics or new data. To solve this, we found the new technology, actually not the new technology, but it is the ancestor of the BPF. We found that eBPF can help them in a very easy way because you don't need to instrument your code. You don't need to redeploy your application because you don't need to write code to collect new data. So that's their pain points. And on the correlation side, Ddosify is a native integrated between observability and the load testing side. So we can automatically correlate data and automatically find the bottlenecks in their system, and we can alert them.
So that's kind of actually interesting now when I think about it. Typically, the performance or load testing tools are telling me that something is not performing well, right? But unless we are talking about a commit that was done an hour ago and contains 5 lines, and because of those 5 lines, it starts misbehaving, typically those tools are not telling me what's wrong, right? It's just telling me that something in the system somewhere is misbehaving. And now go and randomly find out what that something is. Especially, I imagine if I would start load testing on a system that was not load testing before, right? So we're not talking about the latest commit and things like that. I could probably spend hours, days, weeks, months trying to figure out, okay, so which part of the code, which function, which service is actually the main culprit in all that?
Yes, exactly. Actually, load testing is best for the company types who receive predictable traffics in the predictable time periods. For example, ticket selling companies, just example, Ticketmaster. They don't have continuously receive lots of traffic, or any ticket selling based companies. They have some event periods and they have to be stable, and they shouldn't be down at that ticket selling period. So this is best for the companies who receive predictable traffic in the specific time periods. Once to answer your question, yes, the traditional load testing tools is just works on the first stage of the problem. As I said, they are sending traffic and they are not analyzing your code. So the system under test is a black box for them.
So what would be the solution? Somehow to involve, I guess, traces or something like that, right? To start trying to figure out which part of the trajectory of all those requests is involved, right?
Yes. The solution is actually they are integrating the customers integrating the load testing tools with the APM tools. So what they are doing, as I said, they are correlating the received traffic with the collected metrics. So they just want to see that there is a performance issue at this class and this method at the line where we are connecting with the database for this SQL. So that's why trying to find the performance issues. But we are trying to automate this process without integration, without manual effort, without setup effort. So the first option, at initial, we think that we can use OpenTelemetry. So the customers can send their OpenTelemetry data to our observability backend, so we can correlate the received and sent data to find the bottlenecks. But the industry shifts to the eBPF side because it makes the application performance faster. So they don't need to manually write code, as I said, and it works in the kernel level. It collects lots of data instead of manual telemetry collection.
So have you had any pushback from people wanting to use eBPF?
Oh, what do you mean by the pushback?
Like, for example, one of the potential problems with eBPF is that if I allow you to install your agent or something like eBPF, I'm effectively giving you control of my system. One of the potential problems I can imagine is that I have to have a lot of trust in you, right? Because I'm giving you keys to my kingdom in a way.
What if the agent is open source?
Yeah, I mean, open source is better because open source means that I can inspect the code and find out whether you're doing something malicious and stuff like that. So it's a better option, but let's face it, how many companies, teams, individuals do inspect open source code, right? 0.1%, something like that, right? There is still that kind of level of trust that is required for, I mean, for some people, no, some people don't know what is eBPF. So kind of, hey, it's cool. It's yet another agent, right? But for some people who do understand eBPF, that's a potential challenge. Now, certain projects establish that level of trust. Like very few, if anybody, is doubting Cilium. And especially since Cilium has massive contribution base, right? Many eyes are on it. And I can reasonably say Cilium is safe, even if I never go through the code of Cilium. I know that there are many people from many different companies doing that. So kind of, I trust you, right? And Liz is cool. I trust Liz, right? But for smaller projects or projects that are just coming, I imagine that could be a challenge.
I think this issue is also valid for the current APM companies agents. They make it open source, but they are listening to your network connections. They are listening to your traces, the database connections, your queries. I think this is also case issue for the current open telemetry solutions. I see no difference between eBPF agents and the open telemetry agents. On the other hand, if you are concerned about the security, because it works on the kernel level, as far as I know, Fatih, I think he knows better, but there are some verifications, which validates your eBPF agents, doesn't touch your sensitive security areas. Am I right, Fatih?
Yeah, the eBPF code runs in the sandbox environment, not in the kernel. And the verifier verifies the code before executing it.
So let's say magically, people aren't using APMs today, because still a lot of people aren't. What would be your recommendation? And again, sort of try to keep Ddosify off the table. I know it's hard to do. Where should people start today before they even start inserting APMs into their applications?
Oh, so on the eBPF side, right? How they start?
Or eBPF or otherwise. It doesn't really matter.
To monitor their system?
Let's say I've got a brand new application going out. I am not using any of the APM vendors. I'm going to put you in that same bucket. I'm not using any of the APM vendors. And I'm trying to figure out, okay, what is my step one? What should I do today? It sounds like we've got two paths. And actually there's three. We have the classic ways of doing things. We have open telemetry way of doing things. And now we have the eBPF way of doing things. So how do I make a decision of which way do I go?
If I have a single node application, so I can just trace the web server logs. That will be okay, I believe. If my app runs on some of the cloud providers, they have great solutions. They have Stackdriver, etc., CloudWatch. So that will be okay, I believe. But if I have a distributed architecture, so I have to monitor this architecture, I have to monitor the infrastructure. So there are, I believe, two solutions for this. Actually, three solutions. The first one is if it runs on the cloud provider again, so I can use the native solution provided by this provider. for example, CloudWatch, etc. And that will be okay for a while because I don't need to add new dependency because to add, for example, an APM company's products to my code base. But if I receive lots of traffic from different regions and maybe I have multi-cluster infrastructure, then I believe there are two perfect solutions. The first one is the classic traditional APM solutions with OpenTelemetry or any other custom telemetry collection agents from the APM companies. And the other one, the new one, is the eBPF. So if I want to instrument and collect custom metrics, still I believe eBPF is not capable of do this in the application level. But if I just want to monitor the infrastructure, so which node is live, which node is down, and what is the CPU percentage of my nodes, and I believe eBPF is no-brainer solution for this. You can easily integrate to your system. You can use open source eBPF monitoring tools, or you can use some of the new commercial eBPF observability and monitoring tools.
So if people haven't done that at all in their past, where would you start? Let's just say I'm somebody that's got maybe 2 or 3 years of development experience. And now I've been tasked with coming up with, we need to monitor, trace, and whatever, right? And again, let's keep it simple, a single node application. Where would you start? Because to me, eBPF doesn't feel like the place to start.
Yeah, I got the question. Maybe for now, I would use Jaeger. Jaeger is very pretty simple to use. It supports OpenTelemetry. But maybe the end of this year or the beginning of next year, just with a single command, which installs the eBPF agents, you don't have to collect OpenTelemetry metrics. So it would be more easier than the traditional one. So that's why we will see the future of the observability. So to answer your question, if I am a 2 or 3 years of experienced engineer, I would go with Jaeger right now, or any other open source observability backend solutions. I can instrument your code with reading the documentation, but to monitoring the infrastructure or low-level collections metrics, I think eBPF will change the how we work. It will be more easier. We don't have to write instrumentation code in a very near future.
So with this in mind, where does Ddosify fit into this classic area? And let's go ahead and we'll name what I would consider probably your competitors. New Relic, Datadog, AppDynamics, which to me are the big three in the APM space. Do you consider yourself to be in that space as well? Or where do you fit in?
Right now, no. We are not their competitors right now. Yes, we are building an observability platform, but we are focusing on the performance issue side. So actually, we are a troubleshooting platform. In the traditional way, you can't monitor your infrastructure with Ddosify right now, or you can collect and create charts on Ddosify. It is not possible. And I believe we will not focus on this area for a while. What we are focusing is, you have a performance issue on your system, and you have to find the root cause. You have to reduce the MTTR, mean time to repair. So that's when you use Ddosify. Ddosify will replay your traffic because we are collecting your network packets. Ddosify will collect metrics with eBPF, and Ddosify will find the bottlenecks in automated way. Then Ddosify AI will suggest a solution. If you are allowing us to integrate your GitHub repo, we will open a PR that high probably fix the performance issue. That's what we are focusing on. We are not a competitor of the traditional APM companies. We are not a competitor of traditional load testing companies. We are a troubleshooting platform.
So let me get this right. What you're telling me is you're capturing my data. You see the problem. You open up a PR. I have the choice to go ahead and merge the PR in, and magically all of my problems go away.
Yes, that's what we're trying to build.
So let's dig into the AI side of things. Have you rolled your own large language model? Are you using ones that are already out there? Tell us to where you feel like you're comfortable in saying that.
Yeah. Before that, I have to mention that we have just finished the replay side of this project. The observability and AI side is on the way, so Fatih can answer in technical way.
We did not try any large language models about solution. We want to pre-train the current GPT or other large language models with the current traces from our customers. And we will use the pre-trained model to find the solution. The end goal, you said that we will open a PR and suggest a solution for that customer. We will not use the naive large language models in that area because it's not possible. We will pre-train the models.
So your early days right now on this AI side of things, what has been the most interesting part of starting to do that work? Because I'm assuming you're not coming from a data science background.
I have a master's in computer engineering with an artificial intelligence thesis. I came with that side. So I know how to pre-train a model. So I will use my knowledge, and we have a company. We have 7 people and their knowledge. First of all, we collected data set about traces and metrics, and we will use the data. Then we will pre-train the model.
You're the first person we've had on that actually understands this from an academic level. Explain to me what you just said. How do you pre-train a model? What does that even mean? Where do you even start doing that? You said you collect the traces. So I've got raw data and I'm classifying the data. That much I understand. But then from that point forward, I have no clue what's going on. So what happens from that point?
Starting from scratch for training a model is a huge investment, like millions of dollars, millions of GPUs. For example, OpenAI trains the GPT model for, I don't know, but millions of dollars. We will use the most of the layers of GPT models and pre-train only the last layers. So the model can understand the metrics from only our customers' data, not only from the Wikipedia site. The OpenAI current model is very large, wide. We want to get into the narrow state. So we will pre-train the model and we will use it.
So what is that step? Let's say I've got data. How do I take and build on? So here's the way I sort of imagine this. I have my base model. So it's just a box. I'm wanting to put a few layers of paint on the outside of that box. That's my data, right? So now instead of just having a black box, I have a now nice, pretty pink box. So what does it take for me to create that pink layer on top of the black box?
We have the data, and for example, OpenAI with Azure supports with pre-training. We will feed the data to the system with some hyperparameters like epochs, number of training size, and number of GPUs or something. And after a while, we will calculate the validation loss or something like that to measure the performance of our models. Then the final model is used by our system.
Right. So we've trained it. So how do I know that my model is valid? So my pink layer that I've added on, how do I know that that is valid? Other than I know what data I sent it, but how do I post-validate the pink is good?
We will split the data set into training set and validation set. The training set consists of training, and we will check the model with our validation set. If accuracy is going well, we will use that model.
And what do you determine to be goes well? It passes 80%, 90%? What do you again, early on, I would imagine the number would be lower, but over time, as you feed it more training data, the validation data is also going to be growing at some point to where now you have more confidence in the model. Is that the proper way to approach it?
It depends on the data set, how we split the data into training and validation set, how our data set's size, it always depends. We will check with our earlier training. I can't say 80% is correct one. We will check it.
I guess really what I meant by that is when you first train a model, its correctness is going to be a lower number than later on in time. Is that true or not true?
Yes, that's correct. That's correct.
Okay. So in a perfect world, you would continue training as time
Yes.
goes along, and you expect the correctness of the model to increase over time.
Yes, that's correct.
So Ddosify, not the classical APM model. It is a troubleshooting tool. We'll call it that for the moment. The troubleshooting is only going to be getting better over time as you're adding in your models on top of just the base OpenAI models. Again, that's your plan at this point. What else can you tell us about Ddosify? Is that sort of the 90% story, or is there some little 10% story that people should know about?
Yeah, maybe we can talk about the open source side. We are open core company. On the replay side, the traffic generator or traditional name is load testing sites. We are building our engine as open source. Last year we launched the CLI version, the single node version of the Ddosify, and it got very great traction from the open source community. It has now nearly 7K stars, as far as I know, and more than 1 million downloads. Ddosify, thanks to this traction, has partnered with Docker, Red Hat, and the other industry leaders. So I believe we have a good community support. The other things I have to mention is that we are also focusing on the latency measurement side in the city level. For example, Ddosify can also measure your endpoint's latency in different cities. So it is a very important data for latency sensitive applications, for example, gaming, 5G. And we have customers in these areas. That's all actually. We are open source, we are focusing on troubleshooting, and we can also measure the latency.
And I'm assuming probably you also have a self-hosted. You have self-hosted, obviously, but then you also have a product, a cloud product that you manage as well, correct?
Yes, I missed that. Yeah, we launched the self-hosted version of Ddosify on the GitHub last week. It has no-code UI. It has distributed load generation support, postman imports, correlation assertion with on no-code. You don't have to write any programming language to create user scenarios.
So Ddosify can be found at ddosify.com. Kursat and Fatih, thanks for being with us today.
Thank you for your time.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.